Geek Wisdom. Geek Wisdom.
Disclaimer: the views and opinions expressed in this article are those of the authors and not necessarily reflect the opinions of my employer. Examples of analyzing code used within this presentation are only examples. They should not be utilized in the real-world products as they should be considered as based on limited and possibly dated open source information. Assumptions made within this presentation are not reflective of the position of any private or government entity to which the author is presently employed.
Okay, so let's do a quick review. Servers expose certain functionality to other servers, and they can use a method of sharing information known as web services. So there's two main ways of doing web services. One is known as REST, which stands for Representative State Transfer, and the other is known as SOAP, the Simple Object Access Protocol. REST is an architectural style of how we call the web services using the HTTP protocol, and SOAP is a standard of a recognized format of sending an XML message back and forth. When we use SOAP, it's really just an XML message that's been wrapped in an envelope that conforms to a certain standard to make it easy for different web services to call one another. So a Java web service client can call a .NET server, or a .NET client could call a Java server, or many different ways in between. It doesn't even have to be just .NET and .java. There could be PHP. When using SOAP, the client programs know the way to communicate because they read what's called the WSDL, the Web Services Descriptor Language, which you can think of like the RFCs that we spoke about in an earlier video. Although the RFCs were meant to be read by human beings and then that protocol code it, a WSDL can be read by your integrated development environment, can be read by your programming language directly, and it can then build the necessary stubs to call that web service without you having to worry about a lot of those implementation details. So to you, you just have these stub classes that you would call just as if you were attaching a dynamic link library or another library to a Java module. So when we want to call a web service, if it's on our own server and we're trying to call it over JavaScript, that's no problem. But if the web service is stored on a different server than our own server and we want to call it with JavaScript, we need to implement a proxy, a way of sitting in between to make that call, because a JavaScript cannot call another server directly due to security constraints of how that works. So this is Web Services 201, Part 3. So our examples today are going to focus mainly on the .NET programming language, specifically C#. However, to show some things of how web services work in the back end and sort of behind the scenes, we're going to be looking at PHP and Apache Web Server for some of our examples of posting to a server using the HTTP protocol, just to give you an idea of how everything works behind the curtain.
Do not arouse the wrath of the great and powerful Oz. I said come back tomorrow. You ungrateful creatures think yourselves lucky. Oh. The great Oz has spoken. Oh. Pay no attention to that man behind the curtain.
So remember that the HTTP is a protocol described by RFC 2616, and in our Introduction to Internet Programming 101, we showed there are different commands that can be sent to the server, such as get or head. Today we're going to look at one called post, and these are methods of requesting information back and forth between the client and the web server. And also remember that we use Telnet as a way of testing how we called back and forth. So let's look at a couple of examples. Okay, so for our first example, let's look at a simple PHP program. So what we see here is a Linux server, and on my Linux server I'm running an Apache server and I'm running PHP. So I have a very simple PHP example, which I'll show you. And all it's doing is it's echoing the words data in get, and then there's this array called get, and it's going to spit out the contents of that array. So remember from our internet programming course that what happens is when I issue the get command to the Apache server, in this case, the Apache server is going to execute the PHP program and is going to pass this program in to get the results back dynamically that are going to get shown to the web server. And one of the things PHP does is when you pass in get information or you pass in post information, it nicely formats it into an array that we can use and read those name value pairs to do something with. So in this example, I'm simply going to print out the contents of the array. So without using any web servers, if I were to just want to execute just that program, I can say php get test.php, and I'm not passing any parameters to it, just to show you that what it comes back with is simply data in get is an array, and the array has no values. Now again, remember that I can use telnet to test this protocol out. So I can say telnet localhost port 80, and it's waiting, and then I can issue that command get test.php, and then I'm going to pass those parameters in the get string. So let's say name equals Brad, and say value equals 21. So again, when I hit enter, we can expect that the Apache server is going to run the php get test.php, and it's going to pass those two commands in, and the array is going to come back with the results. And you can see it came back with data in the get is an array, and it has a name value pair name Brad and value 21. So that's how the get works. So I can do the very similar thing with a post. If we were to look at that post test, you can see the only difference now is I'm going to output the value of the post array, not the get array. And I'm going to issue the post command this time instead of the get command. So the way that works is a little bit different. If you were to read about the post command, telnet localhost port 80, the first thing we have to do is issue a post command instead of a get. So we're going to issue this post command, and then the next thing we need to do is we need to say what type of content is it we're sending. So we're saying the type of content we're about to send is called application/xwww form URL encoded, and then the post command then has to say after that you need to issue a content length saying how many characters are you about to send. And in this case, I'm sending 18 characters. And that's so that the server knows once I've sent the 18th character, then I'm done and I can process the command. So you can see now it's not being passed over the URL. It's being passed inside as a message with headers to the server. So if I were to send that message, you can see that I've said I'm going to post instead of get to post test.php. I have to say this is over HTTP 1.0 or 1.1. I said my content type is going to be XLM URL encoded. My content length is going to be 18. And then you see I have my name equals and value equals 21. So that format is URL encoded, but I'm not sending it over the get. I'm not sending it in the URL. I'm sending it in the post. Then when I hit enter to process it, you can see that the post program came back and created that array and seen the same thing, a name, value Brad, and a value of 21. Now in that sense, I had to send my type of application xwww form URL encoded. But the post command doesn't require you to use that content type. I could just have easily had sent XML. And that's the basis for how web services works. Instead of sending URL encoded, we're going to send XML data. So again, let's look at the XML test.php. Now you'll notice with XML, there's no array of information because I'm basically sending a raw set of XML into the server. So I do it a little bit differently. In order to read that information, I use the file get contents, and I say PHP input, meaning read that raw input that you've gotten in as an XML string, and then I echo it back out. I spit it back out just as a test of how things work. So if I were to telnet localhost, I'm still going to issue a post command just like before, but this time I'm going to say my content type is text XML. I still have to say the length, and then I'm going to send this big XML command. So again, I've said post XML test, so it's going to be a post, but now my content type says text XML. I'm sending 280 characters of XML, and then I sent this sort of command saying I'm going to call a method, and here's my parameters in an XML format. Now I could have sent any XML I wanted. This is just a particular XML that I formatted for the server to read. And if you recall, all the XML test does, it should echo that exact same screen back to me when I hit enter. And you see now it's come back and it said HTTP 1.1 OK. It said the current date. It said that its server was Apache. And then it came back and said the data I received. And then there's the XML information that it received. And then it terminated the connection. So you can see from this that an XML is no different than if I sent a post command in. I sent XML data instead of URL encoded data, but it's all happening using the exact same way, following the HTTP protocol, sending a post command to process the XML statement. Now in our previous example, we looked at telnetting and we seen how the data moved back and forth in the get and in the post command on the server side. So let's just take a minute and see that that's the background. That's what happens in the background when you create a form element in HTML. So if we take a minute and we look at this example, form test.html, we can see we have a very simple form, and this form is going to use the get protocol to send that same name and value pair that we did earlier using telnet. So it's a very simple example. It's going to call the get test PHP based upon what the user types in a name and a value. So if we were to go to that in our browser, form test.html, we see there's our thing. We can type as name value pair just like before, say Dave this time, and a value of 45. And when we hit submit, we can see that in our URL, it's changed to get test.php, and it passed that same URL, name equals Dave, value equals 45, and now we're getting the result back from the browser. So the very similar way to the way that it works in Telnet, only our browser has submitted that GET request using that same way that we seen typing it into Telnet. We can do a very similar thing with the post method instead. So if we were to look at the post method, we could take that existing get and we would change the action line now to say method equals post. Now we didn't have to put a method equals guest. We could have, or get. We could have, but by default it's considered get unless you say otherwise. So now we're changing our method to post. So now it's going to post the message, and of course we don't want to call the get test PHP. This time we're going to call the post test PHP because the array that gets built is going to be in a post array now, not in a get array. Let's go to form test now. Now let's try a different name, Freddy, and our value of, I don't know, 86. So this time when it submits, it's going to submit as a post method instead of as a get. So we won't see the data in the URL. It'll get passed that same way we seen earlier through the Telnet protocol. And what we will get back is it will call post test, and it will show data in post is the array, and then the name and the value the exact same way. Now one further way, as an example, we showed that we don't have to send in that URL encoded format. We could instead send XML data. So as an example of that, Let's look at XML test.html. So we're doing a little different here. Of course, our action has changed to XML test.php. Our method still remains post, but we're changing what's called our ENC type. So that's how we're setting a different content type from our browser. So when we do this, our browser is going to submit it with a content type of text XML instead of the default content type of application www form encoded. And we're going to have a text area that we can paste our raw XML into, and then we're going to have our usual submit button. So the difference is now I'm going to send that raw XML data through the post instead. So let's try that. So now we see our spot to paste our HTML. I will take that same HTML that I used in the telnet this time, and I will paste it in there. So that's the XML message that we're going to send. And we know that the way our XML test worked is that it spit back whatever it received. So that's going to send that as a post message to the XML post.php, and it should echo the same results back. And there you have it. You can see now it's all kind of line wrapped, a little difficult to view, but you can see that it's come back with that same XML message. Now, one of the things that, if you're smart, when you actually send through the web browser, certain characters like the bracket character, the left greater than or the less than sign, or the quote characters, they get encoded in a special URL encoded format. And you don't see that here, and that's because I cheated a little bit. If we look at that XML test, I made a little change to the XML test PHP. And before I was reading that raw input and just outputting it. Now I call these two functions URL decode, which takes those special codings for the bracket signs, the greater than, the less than, the quotes, and it converts it back to its actual character. And then HTML special characters, because I want to be able to display that character in the browser, which takes those special characters again and re-encodes them in a different format so they can be seen in our browser. So that wasn't needed to be done when we did our telnet, but our browser automatically converts those characters, so we need to reconvert them back to show them back to the user. So when somebody does a post in a form or a get in a form, or even if they want to send raw XML data through the form, this is to show you that all this is doing on the back end is using those get commands of the HTTP server or the post commands of the HTTP server, setting an appropriate content type and setting that data along the network in order to be interpreted by the server and then returned back to you. Okay, so what we've done is we've shown using PHP that we can contact the web server directly, and we can call the command using post, and we can get our results back. So we're going to use that to sort of peek behind the curtain. So the way that's going to work is we're going to create a special proxy to record the data as it passes from the client to the server, just to watch the message that's going back and forth. Now, from our earlier web services, we never actually got to see the message. It was sort of transparent to us. This is going to allow us to look at exactly how that web service passes information back and forth. So remember that with a proxy, we're basically being a man sitting in the middle between the two communications. So typically, our endpoint directly talks to our web services, but what we're going to do this time is we're going to have a proxy in the middle called web spy. And when the end user is going to point to the proxy is going to record what data it received, and then it's going to forward that data off to the actual web service. The web service is going to respond back to our proxy, which again, we're going to record that data so that we have a log of what's going on, and then we're going to send the data back to the end user. So it's this sort of man in the middle watching the traffic back and forth and recording it for the purposes of seeing what's going on behind the scenes. So the web spy basically spies on the data that's passing along the web service. We then point our client to the web spy instead of the ASMX or the SVC file. The web spy calls the service and returns the result. Let's take a look at web spy. So normally when we write an application in .NET, we might use Visual Studio and an IDE, and it'll have an ASPX file and it'll have a code behind. In this case, I want to do something a little bit different. I'm not going to have any code behind. My code is going to be inside my ASPX file. So this is known as inline code. And when you write inline code in an ASPX file, similar to the way it works in PHP, you put this special command, bracket and a %sign, and that's basically telling the server to run this code on the server. And then we also have this command, script run at server, which we can also use to then define actual code that's never seen by the user. It's run on the server and then the results are returned. So the way the web spy works is we created a little method called write to log. So that just lets us pass in any message that we want, and it's going to create a little log file called webspy.log, and we're going to use that to see what's happening behind the scenes. And then we created a little function called wsCallBasic. So wsCallBasic is going to actually call the web service. So once we've received information from our client, we're going to then send that information off in a post string, just like we've seen, to the actual web server. So that's how that works. We're going to write to the log. You can see here where we write to the log. And then we're going to split out the headers that we found in that file because we want to forward those same headers along. And we're going to use the web request method, which allows us to connect to a URL and send that post message. So we're going to send the exact same content type. We're going to send the exact same headers. Here you can see that we're going to send the message post. So just like in the telnet where we type the word post, that's what that does. We're going to set that content type to the same content type that our client tried to send. And then we're going to get back the results. And it's going to get stored in this string called results. We're going to log that to the file, and then we're going to forward that information on. So then here we're keeping track of the actual web service. So the real endpoint is going to be our hotel reservation service. So that's what the web spy is going to actually call, and we're going to point our client to point to this web spy. And I'll show you that in a minute in Visual Studio. Okay, so let's look at the forms application that we created for our travel management system that talked to our hotel reservation service. So when we originally set this up, we imported its WSDL, and the WSDL sort of generated this app.config file. And inside it, it defined an endpoint. So this is how the web service knows how to communicate with our actual hotel reservation service. It's going to contact this SVC file to get the results back and forth. So what we're going to do in order to spy on it is we're actually going to repoint that. Instead of pointing to the web service, we're going to point to our web spy.aspx. And then inside our web spy, you can see that we have defined a real endpoint, which is the actual hotel reservation service. So our client application is going to call the web spy. The web spy is going to record the results that it receives. Then it's going to call the actual real endpoint, get its results back, record that for us, and then forward it back to our client. So our spy is acting in the middle, recording on both sides so that we can see the mystery that happens behind the curtain. So let's run that. And let's pick a check-in date, a check-out date, and a reservation name. Then we'll hit the Make button. And just like before, it should send that off to our reservation service, and we get a message back, reservation request has been submitted to hotel. But because we pointed to the web spy, we can then look at the web spy and see what actual data passed back and forth between our client and our server. So let's look at that. Our log file was put in our temp directory, webspy.log. And we can see each time we recorded what happened. So the first part of the message, we recorded the headers that were sent by our client to our server. And then we recorded the XML that was sent from our client. So that's what this looks like here. So that first part is our SOAP envelope that wraps around our message. Oops. And our message is simply an XML called make reservation that sent that reservation line over to our service. So just plain XML that was sent in a post message saying, please make a reservation. Here's the reservation line and the date and the name. So then remember that our web spy then took that exact same XML, made a post to the web server, and then received its results back. So we can see a little bit lower, here's the response that came back from the server. Now we just returned an empty result in our SVC web server, so we just get back a very empty statement, also wrapped in a SOAP envelope with no data back. Now we could have returned a response, but if you recall in our earlier presentation, we didn't actually return any result, but that's where the result would come back. So you can see all this calling of the web service and all of this importing of a WSDL, all it's doing is defining that XML that's going to move back and forth as a post statement over the XML, over the HTTP protocol. So this pretty much wraps up Web Services 201. You've completed the final part, part 3. But I would like to take a moment and look at things from a slightly different approach. Let's revisit top-down versus bottom-up, putting together all of the things we've learned over these past few learning presentations. So we designed a travel management system, and we did it by describing each of the various components to make it work, a process known as functional decomposition. And we implemented those functions using both components and web services. An important aspect that we needed for our system was to be able to call different hotels to make reservations, or different other reservation systems to make reservations in those systems. And to do that, we didn't have to create a conference or schedule a bunch of meetings with all the different companies all over the world and get them all to agree on a common format. That wasn't necessary. We could allow each of those hotels to create their own reservation systems and to publish to us what is known as a WSDL, a Web Services Descriptor Language, and that allowed us to then call those various services in the format that they defined on their own. So they had their own bottom-up approach to designing it, and they shared that approach with us through their WSDL, and then our application could read that WSDL to actually implement things. So recall, this is very similar to earlier methods. For example, what was used at universities. They published the request for comments that describe the various nature of protocols, such as how the SMTP or the POP3 or even the Telnet protocol should work. The only real difference between what we're talking about today and what was done then is that RFCs were designed to be human readable. A person read the document to figure out how it worked, and then they wrote the code to implement that specification. WSDLs are designed to be machine readable. So when you go into your Visual Studio or you go into your Java and you call your WS import command, it can read that WSDL and understand how to create the necessary stubs, the necessary code that will call the web service. And we've seen from looking at the detailed level that all those stubs are really doing is raw calling the HTTP protocol in a post format or in a get format and sending the same data that we would see if it was a form post, only we may be sending XML data back and forth instead of URL encrypted form data. So this forms a bigger cycle, which I like to call Brad's design continuum hypothesis. And it sort of works like this. Someone out there has an idea. This idea was coming from the bottom up. And they went through hypothesis, experimentation, trial and error to try to get something to work, to try to implement their idea. In fact, Thomas Edison has been quoted as saying that he didn't fail 1,000 times. He simply discovered 1,000 ways that don't create a light bulb. So in the beginning, in this bottom-up approach, in this world of experimentation, in this world of trying to figure out how things work, it's a hodgepodge of what I like to call loosey-goosey soup. You're like a pioneer discovering America for the first time. Or you might be a cowboy in the Wild West exploring the new frontiers. In those days, if somebody threatened you, you would just shoot him in a fair fight. It was only much later that society stepped in and said, well, maybe shooting your neighbor at noon hour in front of the saloon isn't the best way to do things. Maybe we could have things like trials and juries of our peers and maybe imprison people. But prior to that, it was really just a free-for-all. The rules weren't as tight. There wasn't as many descriptions of what you should do and what you shouldn't do. Now, one of the things that tends to happen during this initial pioneer stage is if you're a person who has the skills and the knowledge, who's learned things through trial and error and experimentation, you get regarded as a hero or maybe a genius because you've figured out how to do things that others haven't yet figured out, maybe because they're afraid to try. We can think of this time as a very agile process. Development of new things and ideas can occur very rapidly in this stage as we play around with things and we try to figure out how things work. But what tends to happen after this is that we collect data, and all of us are collecting all this data and it's all coming together, but it's not necessarily organized. It's very haphazard. It's very hodgepodge. So we form committees. We form groups that come together to try to put all this data together and look at it from different perspectives, maybe from a bigger picture. Committees begin to form. Some of the bigger questions of how it works are discussed. These things are documented. Now, the processes here can be very bureaucratic. And those that were initially involved, they might tend to lose interest because what was once a fun, exciting, and new, it starts becoming drowned in what they might think of as routine and mundane. Now, this is necessary. It's necessary for the evolution for us to grow, that we have this information documented so that we can share it, so that it becomes common knowledge to everybody. But those people, those geniuses of the past, kind of get left in the past. So a little later on, a new generation will enter the fold. This new generation starts off with that common knowledge and skills that were generated by those bureaucracies, by those committees. Generally speaking, they have no knowledge of the time, the trial and error, the sweat and the tears that brought them to the place that they're already at today. From their point of view, all this stuff has already been known. It's common sense. It's obvious. The current generation really can't understand what a world was like without the internet or without the web. It's just always agreed, or without texting, or without smartphones. Now, some of the people in this new generation, they will look at that knowledge of the past, and by standing on the shoulders of the giants before them, they're going to develop new ideas, and they're going to create a new world, a new set of pioneers, a new set of standards, and the cycle continues. Now, I mentioned earlier I favor the bottom-up approach because I like to live in that fun place, that area of discovery, that area of experimentation. And I view that committees and that bureaucracy as a sort of humdrum, not a necessary evil, but an evil just the less. Now, there's many people that love to work in that area, that love to take that information and love to organize it, and that's great. It's just not the type of person that I am. And both are needed, both are interrelated in order for the cycle to continue, in order for knowledge to grow. So as you watch these videos that I've created and other videos that interest you, you're watching knowledge of the past, some of which you probably use implicitly every day in your life, but don't fully see how it all came together. How individuals and single ideas built upon this system from a ground up, from a grassroots perspective. And now it's available for you to use for whatever your imagination can conceive. So have a great and happy journey.